says use the product and quotient rules for radicals to simplify radical expressions. We're going to start simplifying these things by basically doing that factor tree. Remember, when we have square roots, we're looking for 2 of a kind. When we have cube roots, we're looking for 3 of a kind, and so on and so forth. So in this one, we have a square root. We can break this guy down to different factors. So what's 2 numbers that multiply together that give you 18? 6 and 3. Maybe you said 2 and 9. Maybe what, it doesn't matter just as long as you know what those 2 numbers are. You could have different ones. So I have 2 and 9, and then I'm going to break down the 9 to 3 and 3. Okay. So I have a pair of I have a pair of 3s. So I'm going to write that out one time. And then, this guy doesn't have a pair. So, he's left on the inside of the square root. That poor guy, he's left in the kennel. So you can only come outside if you have a pair. Okay? Okay.
You're going to pick up the vector here.
All right. So let's do the next one. I got 360. The square root of 360, again, looking for pairs. How do you want to break this thing down? 36 and 10. Perfect. And now 36. 6 and 6. Right there. I'm going to stop. You can break down 2 and 3, 2 and 3, but I would probably just circle the 6s and be done. And then the 10, 5 and 2. All right. So I got a pair of 6s. Take those on the outside. And then, both of these guys are left on the inside. They don't have any pairs. You got to leave them alone. Just multiply them back together. 5 times 2 is 10. So we end up with 6 root 10. Before you circle it, just double check to make sure, like 2, the square root of 2 and the square root of 10 can't be broken down and found any more pairs. And then on a quiz or test, guys, this is the beautiful thing, is you guys have these fancy calculators, at least a lot of you guys do. You can grab that fancy calculator. I can grab mine out of my bag here. You guys can take these fancy calculators and just double check. I should get the equivalent square root. I should get equivalent fraction. So if I do the square root of 18, I'm going to get a decimal. That's 4.24, right? Well, I simplified and got 3 root 2. So when I do 3 square root 2 and press enter, I should get the same decimal, and I do. So I know I've done it correctly. If you're getting a different decimal, because sometimes what you guys do is you don't know where to put the 3 and the 2. Do I put that on the inside or the outside? If you do 2 square root of 3 and you put them in the wrong spots, you'll get a different decimal. Now you know you did it wrong. Okay, so pairs come on the outside, they're freed, and then the guys left on the inside don't have any pairs. Okay, so you can always use your calculator to kind of check your work. Okay, so when I take a look, I got the square root of 96. What is it? 8 and 12. So 8 times 12 is 36. That works. Okay, now if you're not sure, so 8 times 12 is 96, excuse me. If you're not sure on what that factor is, well, if you didn't know it was 8 and 12, well, you could try 2 and whatever, right? 96. If it's even, you can always divide by 2 and get 48. So you got lots of different options. All right, so let's break down 48, or 8 and 12, excuse me. Break down 8 and 12. 4 and 2. That's 2 and 2. So we got 2 and what, 6? 2 and 3. Seriously. All right, we're looking for pairs. All right, so use different colors. I got a pair of 2s here. So I write that one time. All right, I got another pair of 2s. I write that guy one time. And then, this 2 and this 3 are left on the inside. Anything that is on the outside gets multiplied together. So 2 times 2 is 4. And anything on the inside gets multiplied together. 2 times 3 is 6. So we end up with 4 root 6. Okay. Again, you can always double check that in your calc. Type in the square root of 96, type in 4 root 6, and you get the same decimal. All right, does anybody have questions? All right, so now on D, we have cube roots. And when you see that little index of a 3, then we are looking for 3 of a kind. So you want to go ahead and break this guy down. Maybe you want to do 8 and 10. And we can break down 8 as 2 and 4, 2 and 2. And then you can break the 10 down as 2 and 5. And again, we have an index of 3, so we're looking for 3 of a kind. So we have 3 2s right there. Circle all 3 of those and write that 1 time. And then these two don't have a 3 of a kind to go with, so they're going to be left inside of that cube root, 2 times 5. So my final answer, 2 times 5, we should get 10 underneath. That's the final answer for that one. We should get 2 cube root of 10. That's equivalent to the cube root of 80. Okay. So same idea when we look at E, we have the 4th root of 288. So now we have an index of 4. Now we're looking for 4 of a kind. Okay. We take a look. I break down 288. Maybe you want to try 2 and 144. Maybe you want to do, let's say 12 and 12. That works out nice. Maybe you want to do 6 and 2. 2 and 6, either way. And then we got 3 and 2. 3 and 2. So now we're looking for 4 of a kind, and what I see here is I've got these 2s. I got 1, 2, 3, 4, so I write that 1 time. Now when I take a look at what's left, I see at the ends I've got a 3, I got a 3, and I got another 2. So those guys are left inside of that 4th root. So I've got 2 times 3 times 3. So final answer, I end up with 2. And then the 4th root, 2 times 3 is 6. 6 times 3 is 18. So I get the 2 times the 4th root of 18 is the same thing as the 4th root of 288. Okay, so be very careful. You want to look for what the index is. That's what you're trying to get. How many? So when we look at F, I've got the 5th root of 96. So again, we're looking for 5 of a kind. I've got 96. I want to break that down. So 96 is what? 3 and 32. And then we can break down 32 as 4 and 8, which is 4 and 2, 2 and 2 for 8. And then 4 is 2 and 2. Now this time we're looking for 5 of a kind, and I can see that I've got 5 2s now that I can circle up. So I've got 1, 2, 3, 4, 5. I write that 1 time on the outside. And then I take a look at what's left, and then I got this, this little guy here. He's still left inside of the 5th root. So final answer I should get there is 2 times the 5th root of 3. All right, so let's take a look. We got square roots here for example 2. Does anybody have questions? Do we need to see one more? No, please. So then we're going to take a look. Okay, you can break these down. We kind of saw this the other day. If I have the square root of x to the 4th, y to the 6th, we could break this down to the square root of x to the 4th, and then times the square root of y to the 6th, kind of look at each one individually. And again, we kind of talked about this the other day. Okay, so we go back. I've got the square root of x to the 4th. All right, if you need to, we talked about, well, you could write out all of these x's. And yes, we are looking for 2 of a kind. 1, 2. So I got x times x, which is x squared. So that's what we're doing. Now, what's the little trick we talked about? on Thursday and Friday when I have a square root of x to the fourth, what are we doing to get x squared, basically? Dividing by 2. Again, square roots, we're looking for pairs. We're just dividing by 2. Okay, so you could write out all of these y's, or just take 6 and divide by 2, and we'll get y to the third. So final answer, I get x squared y to the third. Okay. So you can do the exact same thing here. We have the square root of 12. Again, you don't have to do this. I'm just showing you that if you need to, you can. You can break these down individually. So we have the square root of z to the 8th. Again, we're looking for 2 of a kind. We got a square root. So with 12, we'll break this guy down. What do we got? 2 and 6, 2 and 3. We got a pair of 2's. That goes on the outside. And then, oh, this little 3, he's left on the inside. So far, so good. Now, this is where it gets a little tricky. When we have an x cubed, we can't divide by 2, right? Well, not nicely. We'll get a decimal. We don't want a decimal. Okay, we don't want 1.5. So if you need to, write them out. I got x, x, x. And again, we're looking for 2 of a kind. I got a pair of x's. I write that there. And then, oh, I got this guy here. He's left on the inside. He's inside with the 3. Okay. Now, basically what I do here, in my head, I'm thinking, okay, x cubed I know is x squared times x. Okay. So I know the square root of x squared is x, and the square root of x has got to stay on the inside. Okay. So same idea with this y to the 5th. If you want to, you can write out all these y's. I got 1 pair, I got 2 pairs. That's y times y, or y squared. And then, oh, this guy's left on the inside. Last but not least, you know, if you want to do this, you could too. This is essentially like the square root of y to the 4th, and then times y. So if you like the idea of dividing, just remove one of the y's, and that way you can, you know, take y to the 4th and divide by 2, and you get that y squared on the outside. And then this guy's left on the inside. Okay? So anytime it's an odd or doesn't divide nicely, that's kind of what I'm thinking. Okay? All right, what about z to the 8th? What's z to the 8th, y'all? Shout it out. Just z to the 4th. So final answer, I get 2x y squared z to the 4th, and then times the square root of 3xy. So times that square root of 3xy. All right, questions, y'all? All right, let's do this one. Let's see if we can get 3 of a kind this time. Let's do this and do D. Last one on this page. We'll skip C for today. All right, I got the cube root of 54. 3 of a kind. I got the cube root of x to the 6th. And I got the cube root of y to the 10th. All right, let's break down 54. Factors, 2 factors multiplied together give you 54. What do you got? What are 2 numbers multiplied together give you 54? 6 and 9. Okay, 6, 9. We got 2 and 3, and we got 3 and 3. What are we looking for? 3 of a kind. All right. You gotched it. I got 3 3s there. 3 3s. So I write those guys one time. And then on the inside of this cube root, I've got, oh, this little 2 is left on the inside. All right. Any questions on that? All right, so the next one, I've got x to the 6th. I got the cube root of that. Does that divide nicely?
Yes.
6 and 3, 6 divided by 3 is x squared. Again, if you need to, write out all the x's. There's nothing wrong with this. Just takes a little bit more time. And again, we're looking for 3 of a kind. I got 3 x's, write it once. 3 x's, write it once. Multiply x times x is x squared. So far, so good. Last one. We got y to the 10th, and we got the cube root of that. Now, 10 does not divide nicely by 3. But there is a number that's underneath 10, that's less than 10, that does divide nicely by 3. What is it? 9? So this is like y to the 9th and y. Okay, so we take that cube root of y to the 9th. That's y to the 3rd. And then, oh, this guy's left on the inside. So we end up with 3x squared y cubed, and then the cube root of 2y for my final answer. Final. Any questions, guys? All right. Let's finish up E through I as we go. This is just basic simplifying when we're dealing with multiplication. So as we're looking, 3 times 5, when I have a root times a root, if I have root A times root B, that's just the square root of AB. So if I have root 3 times root 5, that's just the square root of 15. There is no pairs there. There's nothing I can do to break that down. It is just the square root of 15. Okay? So when I have f, the square root of 21 times the square root of x, well, that's just the square root of 21x. 21 does break down to 7 and 3, but there's no pairs. There's nothing for me to simplify. That is all I can do. So far, so good. So same idea when I'm looking at g. I've got the cube root of 4 times the cube root of 2. Well, that's the cube root of 8. Now, the trick here, though, is 8 breaks down, obviously, to 4 and 2, but then 2 and 2. 4, 2, 2, 2. There is 3 2's there. So this can be simplified. Sometimes you can do it. So your final answer there should be 2. So sometimes you can do it, sometimes you can't. Okay, same idea with h. We can multiply these two together. These are both roots that are 4th roots. So 5 times 2 we know is 10. And then I would probably write it in alphabetical order. So I'd do the x's first, so x cubed, and then y squared. Again, there's not 4 of a kind in there. There's nothing for me to break down, so I would just leave it as is. And then last but not least, if you have fractions like this, it's basically taking your tops and your bottoms and multiplying together. So we get is the square root of 2 times b is 2b. And then the bottoms, x times 3 is just 3x. Again, if you can reduce something, you would, but in this case, there's nothing there that reduces. That's just my final. Okay. And last but not least, guys, let's finish up with the quotient. Those were pretty easy, so let's finish up. And I showed you this on the first day. If anytime you have, a square root of a fraction, you can always break it down as the square root of the numerator and the square root of the denominator. If I have the square root of 25 over 49, that's just the square root of 25 over the square root of 49. And we know the square root of 25 and the square root of 49, so we get 5/7. Same thing with b. If I have the square root of x over 9, we know that's the square root of x over the square root of 9. And then we simplify where we can. The square root of x doesn't simplify, but the square root of 9 we know is
3.
3. So we get the square root of x and then all over 3. Okay. And then same thing holds true with cube roots. This is the cube root of 8 and the cube root of 27. And then if you need to, break these down. We just did this one, right? 4 and 2, 2 and 2. We're looking for 3 of a kind, so I got 3 2s. And then 27's what, 9 and 3, 3 and 3? So we got 3 3s. So we end up with 2/3. And do we want to do the last one? Or are we good? I've got the 4th root. Want to do this last one real quick? Sure. I've got the 4th root of 3. And then I've got the 4th root of 16 y to the 4th. Well, on top, there's no 4 of a kind, but on the bottom, that 16 can be broken down. 2 and 8, 2 and 4, 2 and 2. And there's that 4 of a kind here. So on the bottom, I got a 2. And then if I have a 4th root of y to the 4th, that simplifies to what? Just 1y, so y. And then on top, you're just left with that 4th root of 3. You can't break that guy down. So that's equal to the 4th root of 3 all over 2y. Okay, ladies and gentlemen, hopefully you're good to go with cube roots